In this JMP exercise, we'll begin with the ECMO dataset and the 1 year follow-up health status. Because this is a 2x5 table, there shall be 10 rows in your dataset, and you can create this from the counts that were given on table 5 in the Peek et al. Data. I've abbreviated somewhat the categories, but basically what you can see here is that there are 5 rows for ECMO, 5 rows for conventional management, 5 rows within ECMO for the 1 year outcomes, and a matching 5 rows in conventional management with the 1 year outcomes, and then the N. So again, let's remember to specify our N as a frequency. So select that column, columns menu, pre-select role, frequency. And you can see here in the columns listing that N is now specified as a frequency. Have also value ordered the 1 year status such that it will show up in the correct order. Because JMP brings things in alphabetical order, without value ordering, you would not have the correct order you see here. So we'll go and select this column, columns, and then down to value ordering or column properties. So we need to go to column info. And then under column info, we select value ordering. And then you see here, I've put them in the order by selecting move up and move down to be better, somewhat better, same, somewhat worse, and worse. And press OK. We can do the same value ordering. Value ordering for the treatment group. And I'm going to move conventional management down so that ECMO comes first in our tables. Press OK. And now you can see here that both variables have been ordered, so they appear in the output in the order that we'd like them to appear, as well as N as a frequency. And now I will go to Analyze Fit Y by X. You can see that my N is already been specified as the frequency. I will put 1 year status as the Y and treatment as the X and press OK. And you can see here now the results of our value ordering. Without the value ordering, you can compare this to the notes where I did not value order the treatment. ECMO was on the bottom and CM was on the top. Now with value ordered treatment, ECMO is on the top and conventional management is on the bottom. And our 1 year statuses are in the correct order that we want. This seems like a small thing to do, but it can become very important, especially if you are transcribing results out of a table into a Word document and you have things appearing out of order. Your table may have them in order in your Word document, but your table in your output may not. And it's entirely possible that you can record these incorrectly. I know that I have done it on more than one occasion. So if we are testing an equality of proportions between ECMO and CM, what is it that we're really looking at? So under this red drop-down arrow on contingency table, I'm going to remove the total, and I'm going to remove the column so that only the row percentages remain. So again, that's under the red arrow, remove total, remove column, leave the row percentage. And what the question is really asking here with multiple proportions is this 17.3 statistically significantly different from this 6.5? And is 9.6 different from 6.5? And is 17.3 different from 16.1? And is 34.6 different from 41.9? And is 21.2 different from 29.0? It is not asking if the proportions are equal across the outcomes. It is not asking if all of the proportions are equal, that is, are they 1/10 of the total response. It is asking across ECMO and CM, are the proportions of the response equal? Our default or null hypothesis is that they are all one proportion. If I go back up here and add total percent in, you will then get the average proportion for each outcome. So ignoring treatment group, 11 out of 83 or 13.3% saw better 1 year later, reported being better. Our question of interest here is, does this 17.3 deviate from 13.3 more or less than the 6.5 deviates from the 13.3. Ignoring treatment group, this right here is our expectation of what the response is. Given no other information, someone with ARDS would be told that they have a 13% chance of being better 1 year later. Now that we have treatment group information, our question is treatment group related to the outcome? Is there an association with the outcome at 1 year based on treatment group? Are these two variables, 1 year status and treatment, related? That is our null hypothesis, says they are not, and that this is the best information that we have. Our alternative hypothesis will tell us that knowing treatment group gives us better information. What you can see here is that with these 5 groups, we've got this warning. 20% of cells have expected counts less than 5, chi-square suspect. So let's take a moment to investigate the expected cell counts. I'm going to remove total, I'm going to remove row, and I'm going to add back in expected. So you can see here that we observed 9 ECMO that were better under the null hypothesis of what was 13.3. We would expect to see 6.89 or 7 participants. We saw 2 in conventional management. We would expect to see 4 under the null hypothesis. We saw 5 ECMO somewhat better. We would expect to see 4.4 or 5 people. So this is actually relatively close, as is the rest of this for ECMO. Our observed are very close to our expected. Similarly, we can actually see here that our observed are relatively close to what were expected in the conventional management. However, the 20% warning has popped up because of these 3 expected values right here. All 3 of these have an expectation of less than 5 expected values. And in fact, we actually saw less than 5 in 2 of them. So remember, it's not about what's observed, it's about what's expected. And our warning has told us that we should not continue with these test results right here. No matter how much we like these test results, they are not valid because of this warning right here. So we have 2 options in this case. We can ignore it, which we're not going to do, or we can collapse our cells or do a Fisher's exact. Let's back out of our data table and we will collapse our cells. You have 2 options here. You can create a brand new data set, or we can simply alter our 1 year status. And that's what I'm going to do. I'm going to create a new column here, and I'm going to go status 3 categories, or you could call it combined if you wanted. So this will differentiate between my 1 year status. I don't recommend that you change the names in the original 1 year status, because when we do Fisher's exact, we'll need to go back to those. So I've done a new status. Now, you can build a formula, and I'll show you how to do that in a moment, or you could simply recode them, or you could just type it out yourself. Better. Oops, see what I did here? 3 T's. Need 2 T's. Same, worse. And then I could select these, copy, and paste. And then just use the status 3 categories in your analysis. If you'd like to build a formula, then go into column information, formula, edit formula, and that brings up the formula window in JMP. Let me put this into view here. There are a couple of ways to do this. You could go through an if then else statement. So I could say conditional if 1 year status comparison equals, and then type in better. Then I want it to equal better. To get additional rows, you use this fancy little caret up here and double click it to get another row. And you would have to do this 5 times for the 5 different statuses. This is an if then else statement. I think it takes too long and you have to remember what the categories are. So I'm going to press delete and we're going to go into the shortcut for matching. So in this formula, I want to say 1 year status. So put that in here, 1 year status. Then I'm going to hold the shift key and under conditional select match. And you will see that all 5 options came up. Let's do that one more time. Press delete. In my no formula, I want to click on 1 year status to put into the blue box. Hold the shift key, select match. And now you can see all 5 options. And I'm simply going to copy or Control or Command C the better and put that where I want it to be changed to better. You could also type it in. I'm going to copy and paste same, and I'm going to copy and paste worse. And press OK. And you can see that I now have a plus sign next to my column in the columns menu over here in the sidebar. That indicates that I have this formula. I'm going to save my data before I continue. And now I'm going back to the Analyze menu, Fit Y by X. My N, my frequency is still in there. That's good. My status 3 categories now becomes my Y, and my treatment becomes my X. And press OK. And you can see now the results that are in the lecture notes, the same likelihood Pearson results. So our formula has worked. It has taken the N and added it up for the better and worse categories. Now again, before we can interpret this, we haven't gotten the warning from JMP, but we can go ahead and check our expected values. Let me remove my total and column percents. And here are our new expected values. 11.3, so 12, 9, 32, 7, 6, and 20, if we round up, because remember, you can't have 1/10 of a person. So we have an expectation that all of our cell values, now that they are collapsed, will be greater than 5. We can then proceed to interpret our likelihood ratio chi-square test here and say that we fail to reject the null hypothesis and that the expectation, let me put our totals back in here, is that the proportion of respondents across treatment groups is similar across the 3 categories at 1 year. We expected to see roughly 22% in the better group, and that seems to be where our sort of largest deviation is, but it's not statistically significant. So here you can see that we have no difference in the proportions across treatment groups within each of the categories. Treatment group is not related to a differential outcome at 1 year, or there is no association between treatment group and 1 year status when it is coded as better, same, or worse. So now back to our other option if we wanted to do a Fisher's exact test, because we did violate the expected 5s using it as all 5 categories. I'm going to go back to Fit Y by X. I'm now going to put the 1 year status back as Y. The treatment is X, and again, since N was pre-specified, it is already in the frequency. Press OK. You can see I have my chi-square warning here that my cells are suspect. Again, we've already looked at the expecteds, and we know that it is these 3 right here that are giving me the problem. And so I am actually going to ask for a Fisher's exact test. That is up here in the main red arrow. And I want to ask for an exact test, and I want to ask for a Fisher's exact test. Because we have a 2 by 5 table, and we have a couple of cells with very small counts, JMP is going to ask us if we want to continue, because this may take a long time. Here's where I urge you to cancel and close out and save all of your existing JMP data sets, because you may have to force close if JMP takes too long. If you have a very large table and very sparse data, you may need to use SAS, contact a statistician, to utilize SAS for a Fisher's exact test. SAS has more computing power and can work a little bit better sometimes. But I have everything saved, so should it end up taking too long or fail to give me a result, then I'm not in danger of losing anything. So I'm going to go ahead and press continue, and you'll actually see that it does not take too long for this test. And there it is right there. So with a Fisher's exact test, the important thing to pay attention to is the two-sided probability. This table p-value is going to change with every data set that you have based on the number of observations that you have and the number of permutations. So remember, Fisher's is taking all of your marginal counts, 52, 31, and all of these, and holding them constant, and then shuffling all of these counts to create the number of possibilities of how you could have observed this data. It's comparing our data to that whole simulated experience and telling us that our data is not unexpected given the distributional results. So using the Fisher's exact for all 5 categories, same hypothesis, are the proportions the same or different by treatment group? We would again fail to reject the null and conclude that the proportions are similar by treatment, or that there is no association between treatment group and 1-year status when it is given 5 options, and we'd report that p-value. And that concludes how to assess multiple proportions in a chi-square situation with either a chi-square test or a Fisher's exact test, or when we had to collapse categories to be able to utilize the chi-square test.